Welcome to another exciting day in mathematics. Warm-up 24 is on the screen. By now, you should be experts at these four. So I'll give you guys a head start. And I'm just going to ask for answers for most of them. Have a couple of you walk me through number 2 and number 4, something like that. All right, copy and go. All right, check with the neighbors, see what they got so we can get this show on the road. Ask them for their answers, see if they got the same thing as you. If they didn't, tell them to give you $5. $5 Coronis. All right. All right, so I just need answers, not the process. By now you should be able to finish this. So turn to your neighbor, let them know what they got for 1A, and then Alexa's going to give us an answer for 1A. What'd you get for 1A? Tell your neighbor, what number? All right. All right, what number did you get, Alexa? Okay, help her out, Miguel. What was that number? 125. Hands if you got 125. That is correct. Just for the sake of it, first we need to rewrite that. It becomes 25 to the power of 1/2 times 3. It's the same as 3/2. Is that correct? Yes. From there, we know that 25 to the 1/2. The 1/2 is a what? Square root. Square root of 25. Put that in parentheses and bring down the exponent of 3. Next, what is square root of 25? Square root of 25 is 5. The exponent of 3. So that means 5 times 5 times 5 is 125. 1B. Let's go over to Allison before she gives us the answer. Tell your neighbor what you got for this one. What'd you get for that one? All right, Allison, go. Like that? All right. So if you follow the process, you should have ended with something like this. However, a little curveball for you. What is square root of 9? 3. So the answer is 7 over 3. So what are we proving with that? Oh, Mr. Q, I think you're proving that whenever we can't take the square root, that's when we multiply top and bottom and we do the whole process. Yes, very good. All right, let's go to 1C. Pass on one, Allison. Before she passes it to someone, tell your neighbor what you got for 1C. What'd you get for 1C? Carlos, what'd you get? Two to the power of 2. Okay. Square root of 2. Hands, if you got that? That is correct. And once again, this breaks into 4 times 2. Square root of 4 is 2. We get that out of there, and we're left with square root of 2. All right. Not bad. Let's go to number 2. Show your neighbor your graphs and what the solution was for that one. And then we're going to have Carlos pass it to someone so they can help us graph this. Miguel, get us started. The top one. Where do we start? positive 1, and then up 2 and 1 to the right. So up 2, 1 to the right, up 2, 1 to the right. Let me zoom out. Something like that. All right. Pass on one, Miguel, so they can help me with the next one. Subtract 2x from both sides. So y equals negative 2x minus 3. All right, so let's graph that. What do? Plot point at negative 3, and then 2 down, 1 to the right. Okay, 2 down, 1 to the right. Graph our line. All right, tell your neighbor the solution, and then we're going to pass someone solution. Pass someone. Autumn, solution. Negative 1, negative 1. That is correct. And it's where both lines, what, everyone? Intersect. That is correct. There it is. All right, let's go to number 3. I need an inverse for number 3. Show your neighbor the inverse. I don't want the process, just the inverse. All right, good conversation. Pass someone, Autumn. Who? Renzo? Renzo, what you get for number 3? All right, help them out. Let's see. Victoria, what'd you get? All right, that's 2. Let's go with one more and see if we got it. Go with, how about, when were we called on in a long time? Julian, what'd you get, Julian? Like that? Also, like that? All right, let's double check that. Let's see. So I'm going to go this way. Change this to y. So y equals 2x squared plus 5. From there, we subtract 5 from each side. Y minus 5 equals 2 times x squared. Divide by 2, both sides. We end up with y minus 5 over 2 equals x squared. From there, we take the square root. This cancels that. And then from there, we exchange the variables. So square root of x minus 5 over 2 equals y, and change it to f of x. Ooh-wee. Julian, let's go. You remind me of me in kindergarten. Let's go. All right. Next, number 4. Let's see. Number 4, I just need an answer for number 4. Check with your neighbor. Answer for number 4. All right, pass someone. Julian, x equals what? Pass it to someone. Autumn. 24. Hands, we got 24. That is correct. And remember, the square root, the 1/2 power becomes square roots. To cancel that, you square each side, and so on and so forth. All right? So, copy the agenda, please. Here it goes. Warm-up number 24 done. We're still in the middle transformation of functions. And so far we covered A, H, and K. Tonight's home plate, 3 more transformations. All right. To have access to the home plate, copy this code, 3YSHZ. Write that down, 3YSHZ, 3YSHZ. So, last night's home plate was this one. Now, since you did the same 3 transformations for squared and cubic, so you should have 6 transformations, yes? All right, so I'll take questions. Which one would you like for me to go over? Which one? The red one? The first one, red one? The blue one? All right. So let's go over that. Let me make some space here. So the blue one, if you write this in blanks, you get G of X equals blank times F, X minus blank, squared plus blank. And right now we're doing for the squared. So H is -5. K is -2, and A is 3. So my new transformation for blue is G of X equals 3F, X negative times a negative becomes a positive, squared minus 2. All right. So let me make a little coordinate plane here on the fly, because I got it like that. Here it goes. So I'm going to graph first f of x equals x squared. So I got -1, -2, 1, 2, 3, 4, -1, 1, 0, 0, 1, 1, 2, 4. And that is my f of x. Next, I want to know where that's going. So turn to your neighbor to know where it's going to go at the end. Where are we moving that at the end? All right, where are we moving that at the end? What do you think, Sarah? Down and to the left. That is correct. However, before that, I need to do this. So, let me zoom in. Here it goes. This point is at -2, 4. Is that correct? -2, 4. However, now that we're going to transform it according to the multiplier of 3, so -2 Now it's going to have the point at 4 times 3 is what? 12, way over here at 12. 12, because we're multiplying times what? 3, Mr. Q. All right, good. Next point, negative 1, 1. Since the multiplier is 3, so my new point is negative 1, 3. 0, 0. 1, 3. 2, 12. And the rest is history because we move it 5 to the left and 2 down. 5 to the left and 2 down. Watch. I'm going to move my vertex 1, 2, 3, 4, 5. So I'm at what? Negative 5. 2 down. 1, 2. So my new vertex should be somewhere here. Same thing with these. 1, 2, 3, 4, 5. 2 down. There and there. And these. 1, 2, 3, 4, 5. 2 down. Got 1, 2, 3, 4, 5. 2 down. A little bit off, but you get the idea. That is our g of x. All right. Now, with the red one, let me just set it up so you guys can see what happened to that one. Same idea. We get g of x equals blank times f x minus blank plus blank. H is 3, K is 5, and A is 1/4. So my new transform function, g of x equals 1/4, parentheses x minus 3 squared plus 5. Now, for the sake of time, this one is going to the right and up. However, let's find out what happens to this 1/4. Let me zoom in. 1/4. Here it goes. According to the new transformation, A is 1/4. So, here it goes. This point right here is negative 2, 4. Is that correct? So my new point is negative 2, but instead of being 4, we'll just multiply it. What is 1/4 times 4? We got 4 over 4, which is 1. So negative 2 goes to what? 1, right there. Next, negative 1, 1. Negative 1, 1. So now negative 1, what is the new value? Well, 1/4 times, what was the y value for this one? The y value is 1. So that is still 1/4. Where's 1/4? Between 0 and 1, somewhere close to the x-axis, right there. 0, 0, 1/4. 1, and then you move them. What was the movement? We were going to move it to 3 to the right and 5 up. But I'll leave it at right there so far. 3 to the right, 5 up, so it's going to be somewhere right here. And 1, 2, 3, 5 up. Oh, my bad. It's over here. All right. All right, go to Canvas, turn it in. I want to see what you did. Should read 6 transformations. Hopefully it looks like this. All right. And then you're going to need 2 graph papers for this session, so make sure set that up. Give you guys some time. Go. All right. So here we go. Our objective for today can transform a function using different parameters. We're still trying to wrap up parameters A, H, and K. And so far through the lens of 3 parent functions, linear, quadratic, and cubic. Okay. So, we already know what a function is. We did some of this, and we can do that. Okay. However, I want us to do a quick activity on your screen. Log in to, it's going to pop up. It's going to send you to DESMOS. And you should end up in this screen as soon as you log in. We have the parent function f of x equals x squared, and the transformation g of x equals x minus h squared plus k, and I included some levers here for h and k. I want you to move them. I want you to notice what happens to the number and what happens to the red graph when you're doing that. Same thing for k. I'll give you guys some time. Play with that. Then from there, talk to your neighbor, see what's going on with those numbers when you move the levers. All right? So, look up to the screen. Y'all ready? Julian over there? All right, here we go. So, you move the levers, but just to make sure we got the same idea, here it goes. I want you to move the lever so that h is a negative number, And look at the graph. What happens to the graph? All right. So, what happens to the graph when h is negative? Tell your neighbor, what happens to the graph when the h is negative? All right. Gio, what happens to the graph when the h is negative? It goes to the direction of the what? Left. Yeah, so when this h value is negative, it should have gone to the left. Is that correct? Okay. So if we change it to positive, obviously it should go to the right. So positive, negative. All right. Same thing with k. I want you to switch it to negative. See what happens to negative. Same thing with positive. And that one is obvious. Positive goes what? Up, and negative goes down. Okay. So, go to the next slide. To that one. So here with a little arrow, change to the next slide. Now we have f of x equals x squared, still the parent function, but now our general rule is a parentheses x minus h squared plus k. This time I want you to move the lever for a, keep it at positives first, and then move on to negatives. Do that right now. see what happens to the function with all positives and then with negatives. So I'll give you some time. Go talk it over to your neighbor. Tell your neighbor what happens when A is all positives, but then what happens when it starts getting into decimals, and then what happens when it becomes negative. Tell your neighbor, please. What happens to A? What happens to A? All right. So let's see who's going to enlighten us. Who went last? Julian, pass someone. Autumn. What happens when A is negative? It flips. Did everybody see that? Yeah, so here goes the lever. Let me move it. Going to the left. There is at 0. There is no graph. But then we go to the negative, and it does what, everyone? It flips. So it does the inverse. It inverts itself. All right? And again, if we move H and K, H, positive, moves to the right. Negative moves to the left. And K moves it up or moves it down. Questions, comments? Autographs? No? All right, go to the next slide. I want you to look at the cubic through that same lens. And again, move A, H, and K. Play with it for a little bit so you guys can see what happens to the graph. Go. All right, thank you very much. Good deal. Move on. So we're back here. So let's see how well you got all this. Example 1, it says, the graph f of x squared is right here. Looking at it through the lens of our general rule, if A is negative 1, tell your neighbor what's going to happen to that graph, please. Don't write it on paper, just tell your neighbor what happens to the graph when A is negative 1. All right. Go over here with, let's see. What happens when A is negative 1? It flips. Hands if you agree with that. That is correct. It flips. Go to the next one. When A is 2, tell your neighbor what happens to that graph. Talk over your neighbor. When A is 2. What happens to that graph? All right, good conversation. Natalia Castro, what happens? It stretches. Hands if you agree if it stretches. That is correct. Let's go to the next one. When A is 1/2, tell your neighbor what happens when A is 1/2. All right. Pass it to Natalia. Pass someone. It compresses. That is correct. Next, what happens to that graph when H is 5? Tell your neighbor when H is 5. Leo, what happens? I couldn't hear. Everyone, it goes to the right. All right. Next, what happened when H is, you substitute a -7 in there? Pass on one, Leo. Geo. Goes to the left. Okay. What happened with K is -7? Everyone. Down. How about when K is 3? Up. And let's go to A1/4. What happens to that when it's A1/4? Compresses. H8. To the right. K -4. Down. And the last one. Tell your neighbor what happens to that graph when A is -1 H is -5, and K is 6. Talk with the neighbor. What happens to it? This one, I want you to write me a word next to each of those on the screen. What happens when A is -1, H is -5, and K is 6? Write it on the screen, please. Write it on the screen. What happens to that, that, and that? All right? All right. What happens, Julian, so we can wrap this up? What do I write next to -1? What do I write? Very good. Flips. And then left. Very good. And then up. That is correct. Go ahead and log out. Once again, I'm going to give you some more practice for tonight. Make sure you get that practice in, people. We need to get this out of the way. And tomorrow's Friday. Remind your neighbor what tomorrow is. Have a good one, everyone. See you guys till Monday. See you good on Monday. All right.